Hello, let's look at this question from WAEC 2019. The name of the compound given to us here is what? Of course, this is an organic compound and it is written as a structural formula, but this is a condensed structural formula. We need to write the complete structural formula to easily name it. Now let's begin. The first carbon here, now I have written it. It's attached to 3 hydrogen carbon atoms. So we have 1, 2, and 3. Recall that each carbon atom must be tetravalent, and that is why we have another bond here, which is now bonded to the next carbon atom that I have written. Now, this second carbon atom has 1 and 2 bonds to methyl structures, 2 methyl. So we'll write CH3, that is one of the methyl here attached to the carbon, and another CH3, which is now 2 methyl structures. Now, this carbon has a bond to the next carbon. So this is the next carbon atom. It is bonded to 2 hydrogen atoms. So this is the first one, and this is the second one attached to these carbon atoms. Now, this carbon atom has another bond to this carbon, the next carbon atom here. And so we have the carbon written, now I've written it here. It is bonded by 2 hydrogen atoms. So we have one of the hydrogen atom and the second hydrogen atom. Now, this same carbon has another bond to this last carbon atom. This last carbon atom is bonded by 3 hydrogen atoms. So we have 1, 2, 3 hydrogen, hydrogen, hydrogen. The total number of carbon atoms in the longest chain is 1, 2, 3, 4, and 5. So each of these carbon atoms has the first one, 3 hydrogen bonded to it. The second one, 1 methyl and another methyl, making it 2. Then the third one, 1 hydrogen and another hydrogen. The fourth one, 1 hydrogen also and another hydrogen. Then the last one, 3 hydrogen atoms surrounding it. So to name it, we start with the longest carbon continuous chain. Longest carbon continuous chain, right? Good. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So which one should we go with? We can either go with this, in this direction, or even straight. But for simplicity's sake, we just make it straight. Is that clear? Numbering, we have this as carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. As well as this can be carbon 1, carbon 2, carbon 3, carbon 4, and 5. Now, where do we actually need to begin the numbering? From which end? To note the end, we must identify whether there is a branch, a functional group, or if there is also a substituent group. But in this case, there is no attached functional group and there is no substituent group except for these methyl that are attached here that are branches. And so we have branch close to this end, therefore this carbon become carbon 1. So we ignore this numbering. Now numbering 1, 2, 3, 4, 5. Because it is 5, we have pents. And to complete the parent's name now, carbon to carbon all through single bonds, right? Good. So it is now an. Is there any functional group attached here? Checking, there is no functional group, and so we have the suffix E. This is now pentane. Then we look at the branch. At carbon 1, is there any branch? No branch. At carbon 2, is there any branch? Yes. We have the first one. At carbon 2, there is methyl. As well as carbon 2, there is another methyl. At carbon 3, is there any branch? No branch. Carbon 4, any branch? No branch. Carbon 5, is there any There is no branch. So these are the only branches located at carbon 2. To simplify this, because it is the same methyl that is appearing more than once, we now write the number 2 and then comma 2, because between number and number it is comma, but between number and letter there is hyphen. So 2 comma 2 hyphen. How many methyl structures are here? There are 2, and then it becomes di. Then we write methyl instead of writing methyl. Is that clear? Good. So instead of writing all of this, we now write this, and this will come before the parent's name. Therefore, the name now becomes 2 comma 2 hyphen dimethyl, then the parent's name pentane. Now this is the name of the structure. This is the name of this compound. Thank you.